Hello friends, welcome back to Digitalk. In this session, I am going to explain you a very important concept of Docker, theoretically as well as along with the execution. Okay, that is called Docker Swarm. So what exactly is a Docker Swarm? So Docker Swarm we use specifically when we have a multi-container architecture, which is scattered around the multiple nodes or multiple machines. So what does it mean? Let me explain you quickly. For example, you have a different host. We have a host 1, which we can refer as a node 1, node 2, node 3 and node 4. Okay, so these are the four node. Okay, it can be your virtual machine, it can be your physical server. Okay, where we have multiple Docker containers are running on each and every node, right? Like this one. Now if you need the management of this kind of a structure where you have multiple containers or multiple installation of Docker which is scattered around the multiple machines or multiple nodes, okay, then it's not feasible you to log into each and every machine and repeat the same task. Okay, for example, maybe you have your own website which is deployed on the 4 different hosts. Okay, and now you have a multiple containers of your website running on each and every host. Okay, now if you have to update your image, or if you have to update your container, or you would like to update your application, okay, and or maybe you want to stop the containers, so it's not feasible for you to log into each and every node and then perform the task again and again for each and every machine and for each and every container, right? So for that we need a centralized solution or a central location, okay, where you can control all of your Docker containers in all of the nodes. Okay, so this is a kind of a orchestration tool, okay, which is used to centralize management of your multi-container Docker architecture. Okay, now if you would like to stop all of your containers, then you can issue the command from here. It will automatically stop all the containers. You would like to roll out any of the new image, you can do it with the help of Docker Swarm. It will roll out the new image in all on each and every node. You want to update your application in the containers, then you can do it with the help of Docker Swarm. It will automatically update all of your applications, okay, from this single location. So it is a kind of a centralized management of a multi-container architecture, right? Now the easy thing is you don't need to install it separately. Okay, it is a native feature of your Docker, so it automatically installed with the Docker. You just need to initialize the Docker Swarm. There are few commands. With the help of that, you can easily set up your Docker Swarm and can manage the multi-container architecture, and that I am going to show you with the execution on my Linux machines, right? So let me first quickly recover all the concept that we have discussed so far. What exactly the use of Docker Swarm? So it is an orchestration tool. So that means Docker Swarm is a native clustering and orchestration tool for Docker containers. So as I said, it is a native tool. That means you don't need to have to install any tool separately. It is bundled with your Docker. Now when we talk about the orchestration, that means it is a kind of a management of the multi-container system. Okay, so this is your Docker Swarm. Okay, and you may have a multiple containers, container 1 2 3 4 5 6. Okay, they could be on a single machines, okay, or they can be on a separate machines. So in a real practical scenarios, okay, you may have a multiple machines in your environment. Okay, so now if you do the management of all these containers or machines or Dockers from a centralized location, then you can utilize the Docker Swarm. Okay, and then you can do the management of complete machines or the containers from a single location, and this is called the orchestration, right? So easily scale services up or down with a single command, that is called the scalability. So what does it mean? For example, today you have a 6 container which you are managing with the help of Docker Swarm, right? And tomorrow you may be feeling that the load of the application is getting increased, my clients are getting increased, and I may need to spin up few more containers. Okay, I need to scale my application. So what will happen in that case? You can spin up 2 more containers easily with a single command. Okay, so I will show you that what is the command and how to scale it. I will show you practically all these things what I am talking about. Okay, now what are important for here you to understand what does the meaning of scalability, right? So as I said, you may have a 6 containers today. Tomorrow you wanted to have a 2 more containers. Okay, then you can scale your environment, which is called scaling up. Now what is scaling down? Now again you would like to scale it down. So there could be a chance that maybe in a week of a time, for 2 days you have a high load in your system, but for rest of the 5 days, the load is normal. Okay, so it could be possible that in a week of time, for 2 days you may need 8 containers, and rest of the 5 days you only need the 6 containers, right? So to save the cost of your resources, specifically if they are running on your cloud, right, where we get charged based on the utilizations. So what you can do for the 5 days when you have a normal load, you can spin up only 6 containers, and for rest of the 2 days you can spin 2 more containers. So that means you can scale up according to your requirement, or you can scale down as well anytime, right? That means, for example, we have scaled our environment or scale up our environment from 6 to 8 containers, and then we can spin it back to from 8 to 6 anytime. So this is called the scalability, and that we can do with the help of Docker Swarm easily with a single command. Okay, so load balancing. Okay, so load balancing again is a very important feature, specifically in the highly available environment. And what does it mean? It's very straightforward. Here again, I'm saying that we have 6 containers. Okay, now if any client is trying to connect your application, which is running on the multiple containers, then how the load will get distributed on each and every container, right? It has to be distributed equally in each and every container. So if the first request will come, it will go to container 1, second request will go to container 2, third will go to container 3rd, and fourth will go to container 4, and similarly it will go to 5th and 6th container. Okay, and then again it will be round robin way. The next request again will go to container 1, then again container 2. So it will go in a cyclic way, which is called the round robin algorithm. Okay, so this is the feature of your Docker, or you can say Docker Swarm, okay, which support the automatically distribute the load, or it is a auto load balancing, which is supported by your Docker. You don't need to worry about the load balancing. Now another feature is self-healing. That means it auto recover from the failures as well. What does it mean? For example, today you have a 6 containers. Okay, maybe due to any reasons one of the container got crashed in the backend. So what Docker Swarm will do, it will automatically spin up one more container for you, right? Because in when we configure the Docker Swarm, or when we created the resources or stack in Docker Swarm, okay, so we have to specify the number of replicas. So number of replicas means how many containers we need in this Docker Swarm. So during the configuration, initially if we have specified the 6 containers, right, so your Docker Swarm will always ensure that 6 containers are always up and running in your system. So here we had the 1 2 3 4 5 6 system. Now if one of the system got crashed, okay, your Swarm will notify it, okay, now one is crashed, so it will spin up automatically one more container for you. Okay, so this is not true only for a single. Even if 2 containers or 3 containers or maybe 4 containers are crashed due to any reasons, it will automatically spin up the few more containers for you, to make sure that at least 6 replicas which you have given initially should be up and running in your cluster. So this is called the self healing. Another important feature is rolling update. How you can update the applications in the rolling fashion to avoid any kind of a downtime, right? If you have a 2 containers, for example, okay, and you are going for deployment of your new application, or maybe you are doing the deployment of new containers which will contain your applications, so you can't bring down your both system altogether, right? So now in that case, if you have a, suppose you have a 2 containers here and 2 containers here, right? So what you can do, when with the help of Docker Swarm, you can initiate the command to update your application, okay, in the rolling fashion. So that means it will update the container 1 first, then it will go to container 2, then it will go to container 3, and then it will go to container 4. So this is called the rolling update. That is, it is updating each and every container one by one, okay, to avoid any kind of a downtime for your application. So like this one, we have Docker Swarm, and we are managing the 6 containers with the help of Docker Swarm, and the current version of our application is V1. Okay, now if you initiate the rolling update of your application with the help of Docker Swarm, so it will first update the first container, then it will go to the next container, then it will go third container. So similarly it will go one by one to other containers. So that means your application will get update one by one on each and every containers, okay, in the rolling fashion. Now if you want to roll back due to any reasons, okay, maybe your application is not up to the mark, it is failed in some testing, okay, it is not working as expected, you want to roll back to a previous version, again you can just initiate a single command, and that single command will take care of the rollback of your application, okay, and roll back again in the same way. It will go in the one by one way to avoid any kind of a downtime. So this is one of the important feature of the rolling update and the rollback in Docker Swarm. Let me give a graphical representation. This is a host A, okay, where we have a Docker and 3 containers are running, and for high availability we have one more node, right? So that in case this host get crashed, we have another one in place, right, to cater the requirement of the applications. Now, for scalability, tomorrow you want to scale your environment and you want a few more containers in the other host, virtual machine or physical server. Then you can, with the help of Docker Swarm, you can scale your environment as well with a single command by giving a single command, right? So all these make a cluster, right? Because they all are running the similar application. So that we call it as a cluster. Okay, so this is a group of Docker host which convert it into a single virtual Docker host. So although it is a separate machines and we have a different Dockers are running in each and every machine, but in a cluster where we have a same kind of application deployed across all the containers, okay, this act as a single virtual Docker host. Just like means we have installed it on a single machine, okay, which is a virtual Docker host. Similarly, if you have multiple Docker hosts, so Docker Swarm will make it as a single virtual Docker host. Okay, and then we will have a Docker Swarm, and for this Docker Swarm you can have a separate machine. Okay, and in this machine you can install the Docker Swarm, and from there you can manage all of your machines. Or you can do one thing, if you don't want to have a separate machine, so out of 3 machines you can choose one machine where you can install the Docker Swarm, okay, which will act as a your manager as well as a worker node. So what is manager and worker node? This Docker Swarm machine where we initiate the Docker Swarm tool, this is called the manager node, because this is going to manage the other nodes where containers are running, and rest of the node where you have the containers are running called as a worker node. So these are the two very important terms in the Docker Swarm: manager node and the worker node. So it's very simple. Where you have initialized the Docker Swarm for the management, this is called the manager node, and rest of the node where you have your Docker containers are running, or you can say your applications are running, referred as a worker node. So now, as I said, you can have a separate virtual machine for the Docker Swarm. If you don't want to have a separate machine, what you can do, out of all the worker nodes, you can choose one machine which will act as a manager node, and this will act as a worker node as well. Okay, so that means a single machine can act as a worker node and it can act as a manager node. Preferably in production environment, real-time environment, we always have a separate virtual machine or maybe a server for the Docker Swarm and separate for the worker node, right? So now I have given you the overview of some important feature of the Docker Swarm. Okay, what are the different features of Docker Swarm and what exactly is the Docker Swarm? So it is a simple tool which is we use for the multi-containers management, specifically when the containers are running on the different hosts or different machines, or which also called as different nodes, right? So now let me show you with the execution how we can initialize the Docker Swarm, how we can configure the Docker Swarm, then how we can register the worker node. Let me come back to here. Okay, how we can initialize the Docker Swarm, how we can register our worker node with the Docker Swarm, and then how we can create the stack or the resources. Okay, and then how we can do the rolling update, or how we can go for the rollback, or how we can go for the scaling of the application just using a single command. Okay, so here is the command. So to initialize the Docker, or you can Docker Swarm, or you can say to set up your Docker Swarm, you only need the 2 commands. The first command is docker swarm init. This you need to run on the master node. Okay, and then there is a subsequent command that you need to run on each and every worker node, right? So once you will run the docker swarm init command, okay, on the master node, it will give you the command that need to execute on each and every host. You don't need to frame this command as well. Okay, you will get it once you will initialize your master node. Okay, so I have 2 machines. This is my first machine and this is my second machine. Okay, these are the Linux machine I have on AWS cloud. So what I will do, I will use my node 1, which is at node 1 and node 2. There are 2 machines. So this node I am going to initialize the Docker Swarm, which will be act as a master. Okay, and by default in Swarm, your master node act as a worker node as well. If you want to create your containers on the master master node as well, then you can create. So this is going to work as a worker node for me as well. Okay, and this will be a pure worker node. Okay, so now this worker node will be on the same machine where we have master. So this join command no need to run on the master node, because this is on the same machine. But apart from that, if you have other machines like node 2, 3, 4, 5, 6 which you want to as a worker node, then you have to execute this command on each and every worker node, right? So let me show you by execution. So this is the first command, docker swarm then init. This I need to run on machine which I wanted to have my master node. So this is my first machine and I want this to be the master node. or you can say the manager node, right? So now here you can see that it is giving you to add a worker to this SWAM, run the following command. So this is the command that you need to run on each and every worker node, right? So let me take it and let me copy it here. Okay, the command is docker swam join, and this is the token that you have received from the master node or from the manager node. This is the IP address of my machine where we have initialized the docker, and this is the default port for the connection. So let me take this and let me execute in my second machine, which is going to act as a pure worker node. Okay, now you can see this node joined a SWAM as a worker, right? So now that means we have completed the setup of the docker SWAM. This is the primary machine which is going to act as a manager machine as well as the worker, and this is the pure worker machine. Similarly, if you have a multiple worker machines, you take this command and execute on each and every machine, then all this machine will join your master node SWAM cluster. So this is all about how you can initialize the docker SWAM and how you can register the multiple worker nodes with your master node or with the manager node. Okay, and this you can check with the help of different commands. Okay, let me show you. Let me go to primary machine and let me command docker node and ls. Okay, so here you can see that these are the two hosts, right? And both are active, and this is a leader. That means this is a master node. So this is my first machine, right? So this is acting as a leader. This is called a manager status. That means if the manager status is leader, that means this is the master node or the manager node, and rest of the node will be your worker nodes. Both are ready, right? This is the host name and this is the ID for the corresponding host. Okay, or you can say for the corresponding worker or manager node. Okay, so now what we need to do, we have to create the resources. Okay, in this particular SWAM. So for that, what we will do, we will take this sample docker compose file. Okay, let me go here and let in the master node, I am going to create this docker compose file. Let me delete the old file contents here. Okay, so what exactly we are creating? So we are going to create a service where we will create the web servers. So we have taken the image for the Nginx web server. Okay, we are going to expose this on port 80, and we are going to have a 4 replicas. So that means 4 containers. Replicas is the containers. So if I am specifying 4, that means we need the 4 containers here, and this is the resource limit. Okay, by default there is no limit on the containers. Okay, it can take any number of n number of resources from your system. So if you want to limit the containers on the utilization, okay, you want to put some limit on the containers, so you can specify with the help of limit. So in this case, each container will have 0.CPU cycle, and then each container will get the 50 MB of RAM only. It will not go beyond that one. Okay, restart policy is something condition on failure. That means if any of the container get failed, your docker swam will docker swam, or you can say your service which we are creating, it will automatically restart the containers. Okay, this is the basics about the your YAML file, okay, which we are going to create. Okay, so let me copy it here. Okay, and let me save it. It is done. So now to create the resources using this particular YAML file, we run the command docker stack deploy -c, then the name of your YAML file and the name of the stack that you are going to create. So why we are saying a stack? Because this is a combination of multiple services. So what we are doing here, we are creating an Nginx web server image which will contain the 4 containers. We will have a 4 containers, right? So that means it is a stack or a bundle of the multiple services that we call as a stack. So we'll run the command docker stack deploy -c. This is the standard command. Then this is the name of your YAML file, and this is the name of stack what you wanted to create. Take it and run it. Okay, it does a lot of different default configuration, like it automatically create a default network for you, and then it create the service. Okay, and this service, you can see this is the name of the service is my_stack_web. So how it has derived the service name? My_stack. This is the name of the stack that we have given, and then this is the service name. So it has taken the stack name as my_stack_web. Okay, so by this way it has created the service. You can see here. Okay, my_stack_web. Okay, so now we can validate the service. So docker service and ls. So now you can see that this is the service that has been created, which is displaying here as well. Okay, and 4 out of 4, that means we have 4 replicas in this particular stack, and all four are up and running. They are using the Nginx image, and this is the port forwarding. This is the default port 80 it is using. Right. So now we can check with the help of docker ps command as well. So docker ps is a command that we use to check the running containers. So now if you see here, when I run the docker ps command, you can see the two containers. These are the two containers. But where are the rest of the two containers? This is on the second node. So if I run here docker ps, you can see two nodes, two containers are here. Right. So what we have done, we have created a 4 replicas, that means 4 containers. And when we ran this command to create the stack from the first node, it has initiated to create the 4 containers, and it equally distributed between 2 machines. It has created the 4 containers, 2 containers here, and 2 containers on the second machine. Right. So this is how it distributes the replicas between your different nodes. Now what I said, there is a feature where if you any of the container goes down or crash, it automatically spin up a new container for you, right? Which is a feature of your Docker Swarm and the services. So what I will do, let me show you as well. So here I will kill one of the containers. So killing the command to killing a container is docker kill and then container ID. So container ID you can check with the help of docker ps command, which shows you all the running containers, and then you can run the command docker kill and container ID. Now if I run the docker ps, now you can see only one container is running here, right? So how many containers we need on in total? 4. So now you can see that now one container is automatically spin up. We have killed that one of the container, and after killing that we were seeing only one container for a few fraction of a seconds, and after that you can see one more container is auto initialize. So this is the feature where which we call as self healing. Okay, where if any of the containers get crashed, your docker swarm and services will automatically spin up the container instead of that. Okay, so if I'm going to kill both of the containers now, let me run the command docker kill. This is the first container and this is the second container. Okay, so now if I check the ps command, there is nothing here. Okay, it will take fractional second of a time, and I can see the two containers are automatically spinned up. Right, that means this is the feature of the self-healing in your Docker Swarm and services. So now what we have learned how to initialize your Docker, your Docker Swarm, how to initialize the master, how to initialize the worker node, how the worker node join your master node, how you can validate. Okay, and then we have seen the kill feature or the self-healing feature. Now if you would like to scale your services, so as I said initially, you can scale up or scale down your services with a single command. So this is the command docker service scale. This is the standard syntax. This is the name of stack that we have created, right? So here I have shown to you when we ran this one, and when we ran the create stack command, our stack was created with the name of my underscore stack and underscore web, right? So now to scale this stack, okay, you have to give the name of stack equal to the number of replicas that you want. This is a single command with the help of to scaling up the application or scaling down. Okay, so let me show you how to scale up. So how many containers as of now we have? We have 4 containers, right? We have given the replica as 4. So 2 containers are here and 2 containers are here, right? So now suppose that I want 2 more containers, total 6 containers. So 4 as of now in my system, I need 2 more. That means total 6 containers I need. So I am going to run this command. Okay, now you can see that it is going to initialize the 6 containers for you. 4 is already there. So now that means it is going to initialize 2 more containers. So if I now show you docker and then ps, now you can see we have 3 containers here. And now similarly, if I go here under the docker ps command, now you can see 3 containers are here. That means with the help of this single command, it has pinned up two more containers. Right. Now suppose again you would like to bring it down. You would like to go back to the previous configurations in the study load. Okay, so again what you can do, you can just change the count of the replicas. Go back here, run this command. Okay, sorry, with the 4. So now it will scale down your environment from 6 to 4 again. So now if I run the command again docker ps, you can see that now from 3 earlier, now it is 2. Similarly, if I go here where we had 3 containers, docker ps, and now we have only 2, right? So this is the way how your auto scaling features work, right? So let me quickly show you how to do the rolling update of your application and then rollback as well. Okay, so again I am going to create a few of the resources in my system. Okay, I will tell you what exactly I am going to do with that. Let me clear up previous configurations. So here again we are going to create a service where we are going to create an Nginx web server with 3 replicas, or even we can do it with 4 replicas. Okay, and with the help of that we are going to create Nginx version 1.21. Okay, and later with the rolling update we will upgrade it to the 1.21 to 1.23 in the rolling fashion. Okay, so let us first create the service. Okay, I will take this content and I will paste it here. So what we are doing, we are creating a 4 replicas. Okay, this is the same file which we have here. I have just removed the comment part. Okay, so here we have defined the parallelism 1 and the delay is 10. Okay, so parallelism means how many containers will be updated at a time. That means if suppose that we have 4 containers 1, 2 and 3 and 4. So if you have given the parallelism 1, it will update the first container and then it will move to the next container. Okay, so if you will give it 2, then it is going to update your 2 containers at a time. It will update first 2 containers and then it will go for third and fourth. Okay, and the delay between the update is 10 seconds. That means the first container is upgraded, then it will wait for 10 seconds and then it will go for the next. Okay, this is the meaning of parallelism and the delay. Right, so now again I am going to create this stack. Is the same command which I have just shown to you. Okay, so now let me check docker and then service and ls 3 by 3. Okay, and then let me run docker ps. So one container is running here and 2 container will be here. Okay, so now here we have given the 3 containers, right? And for 3 it has automatically taken the decision where exactly they need to create the container. So this is taken care by the docker swarm only. Okay, this it creates the containers across the multiple worker node based on the multiple internal algorithms findings. Okay, so now we have created a stack, okay, with the 3 replicas, that means 3 containers. Okay, now suppose that you would like to update your application in a rolling fashion with a new version, right? So now what we will do, we will update the same YAML file which we use to create the stack. And here what I will do, I need the new version of my Apache or Nginx web server, and I need the version from 3. So earlier was 1.21, now I want to upgrade it to 1.23. So I have updated the docker stack file and I have updated the Nginx version to 1.23. Now you can run the same command again which we used initially to deploy your stack. Right, and before that one, let me show you the docker ps output again. So here if I run the docker ps, you can see the current version is 1.21. Right, so now I am going to execute the same stack command by updating the docker version in my YAML file. Okay, now if I go here docker and ps, and let me go here docker and ps. So now here you can see that the current version is upgraded to 1.23 here, right, which was earlier 1.21. Now if I go back to second host and let me see if it is updated here or not. Okay, it is not, it is updating one by one. Okay, it will take some time for the update. So now it is reflecting here. Okay, now see we have 2 containers here now. Okay, and both the containers are upgraded to 1.23. So earlier we had only 1 containers here. Now it has spin up the 2 containers here. Okay, and only 1 container will be on the second machine. Now you can see it is also upgraded from 1.21 to 1.23. Right. So this has been done one by one. It has upgraded each and every containers. Now suppose you would like to roll back to 1.21 again. For that you can run the command docker service update -- rollback and then give the name of your stack. Okay, so suppose you wanted to go back to 1.21 version due to any problems, you can run the -- rollback command in your service update. Okay, and it is going to roll back it to 1.21. So let me see here, it is verifying. Okay, this will take some time. Okay, so again based on the number of containers you have, it is going to take some time, okay, for the upgrade. rollback, sorry. Okay, so now let me show you Docker PS. Now again you can see it is a rollback to 1.21, and now if I go here and run the Docker PS, you can see here now it is rollback to 1.21 from 1.23, right? So this is how Docker Swarm work, how we initialize the Docker Swarm, how we join the worker node with master node or with the manager node, how we create the stack, how we scale the services, and then how we rolling update the applications or how we roll back it if it is required. Thank you.